In this video, we are going to see the joint density and marginal density functions for a continuous random variable. In our previous videos, we saw the probability density functions for single variables, either x or for y. But here we are going to combine both the density functions and we are going to get a joint density function. And from the joint density function, we are going to find the independent densities of x and y, which are the marginal density functions. The joint probability density function is the combination of probability of x equal to x and y equal to y, which is denoted by fxy. It must satisfy all the rules of probabilities. That is, the probability must be greater than or equal to 0 for every x and y. And the total probability, which is integral from negative infinity to positive infinity, negative infinity to positive infinity of f of xy with respect to y and x, must be equivalent to 1. The joint cumulative density function is when p of x less than or equal to a constant a and y is less than or equal to a constant b, which is denoted by capital F, and that will be integral from negative infinity to a, integral from negative infinity to b, f of xy dy dx. Let's see an example. Suppose a person throws a dart at a square dartboard and x and y denote the x and y coordinate of the location where the dart lands, and the middle of the board is 0, 0, which is the origin of reference. The dartboard is 2 feet wide and 2 feet tall, so that the dart only lands on the chart, the dartboard, in this range, -1 to +1 for x and -1 to +1 for y. The density function, joint density function, fxy of xy is given as a function 9 on 16 times 1 minus x squared times 1 minus y squared in that range, 0 otherwise. Now, if you would like to see these probability density functions are, maybe we can make use of some advanced software like MATLAB. I have given the command and syntax, function syntax for the MATLAB. If you use this syntax, graph of the function, the graph may look like this. So between -1 to +1, the dart will land. And it looks like the frequency in the center of this region is more. See the height, the center has got more frequency, where you have got very less number of darts lying in the board. So in the extreme region there, you do not have more frequency, more darts landing. So that's why you have a three-dimensional shape like this. And if you are trying to project this on the x and y line, maybe you may have a flat surface, and let's see how it looks. You may get a diagram like this. Maybe this may be the projection of the curve what we saw earlier. So this is a projection of the function f of xy on our xy plane. Anyway, for this function f of xy, which is defined by 1 by 16, 1 minus x squared, 1 minus y squared, where the graph of the function is given as seen in the previous case in the MATLAB, we can find the total probability and we can check whether the total probability is 1. The total probability will be between -1 to +1, -1 to +1 of this density function. You can easily evaluate this integral and you can show that it is equal to 1. And also, if you're interested in finding p of -half less than or equal to x less than or equal to half, and y between -half to +half, that will be 0.4727. If you're interested in finding the marginal density, then fxx, which is nothing but your PDF for fx, will be integral -∞ to +∞ xy dy. That is, you are trying to vary y and you are trying to find the integral of this. The same way when you are varying with respect to x, then you'll get the PDF for y. So these two formula can be used to find the independent or individual PDF from the combined joint density function. This is the reverse process of it. So in this video, we talked about the joint density and marginal density of a continuous random variable. Hope you enjoyed this video. Thanks for watching.